Hello there. So today we'll talk about blue-green deployment and we'll see how do we do the blue-green deployments, what is the strategy, what is the benefit, what is the drawback of blue-green deployments. So what is blue-green deployments? A blue-green deployment is a deployment strategy in which you create two separate but identical environments. One environment is which we'll call blue is running the current application version, and the other environments we'll call it green is running the new application version. Using a blue-green deployment strategy, it increases application availability and reduces the deployment risk by simplifying the rollback process if a deployment fails. When testing has been completed on the green deployment, live application traffic is directed to the green environments and the blue environment is deprecated. We can understand that with the help of this diagram here. We can see that once all the deployment is successful on the green server, then the load balancer routes all the user traffic to the latest code, and blue server which was running the previous code and gets discarded from the load balancer. So blue-green deployment helps organization achieve automation and continuous delivery while simultaneously avoiding downtime and mitigating the risk. The basic concept of a blue-green deployment is to create two identical production environments, blue and green, that works in parallel. At any given time, only one of these production environment is live. The blue environment, for example, receives all the user traffic while the clone green remains idle. When a new version of an application is ready for release, it is deployed to the green environments for testing. Once the release passes testing, the application traffic is routed from blue to green. Green then becomes the new production environment and the blue goes idle and can become the new green environment for the next release. This process eliminates downtime, lower risk, and makes it easier to release quickly and reliably. Blue-green deployments increases safety and in the release. It also increases the speed in the release. Blue-green deployment is a necessity in any organization with the benefits such as no downtime, mitigated risk, and easily rollback. Organizations should definitely be implementing this deployment strategy. Using your load balancer to direct traffic keeps your blue environment running seamlessly for production users while you test and deploy your green environments. When your deployments and testing are successful, you can switch your load balancer to the target your green environments with no perceptible changes for your users. So at the same time, uh, both the environments will be up and running only for a moment till the time all the traffic is routed from blue to the green. The two environments need to be different but as identical as possible. In some situations they can be different piece of hardware, or they can be different virtual machines running on the same or different hardware. They can also be a single operating system partitioned into separate zones with separate IP address for the two slices. So how it helps in rollback. Blue-green deployment also gives you a rapid way to roll back. If anything goes wrong, you switch the router back to your blue environments. There is still the issue of dealing with missed transaction while the green environment was live, but depending on your design, you may be able to feed transaction to both environments in such a way to keep the blue environment as a backup when the green is live. Or you may be able to put the application in read-only mode before cutover, run it for a while and read in read-only mode, and then switch it to the read-write mode. That may be enough to flush out memory outstanding issues. How we do the database change in blue-green deployment. Database can often be a challenge with this technique, particularly when you need to change the schema to support new version of the software. The trick is to separate the deployment of schema change from application upgrades. So first apply database refactoring to change the schema to support both the new and the old version of the application. Deploy that, check that everything is working fine, so you have a rollback point, then deploy the new version of the application. And when the upgrade has bedded down, remove the database support for the older version. So how does it work? With a few caveats that we'll explore later, Bluegreen pretty much checks all the boxes for an ideal deployment process. It gives you seamless deployments. Users should not experience any downtime. It is safe, low chances of failure, and fully reversible. We can undo the change without any adverse effect. The basis of the Bluegreen method is side-by-side deployments. For that, we need two separate but identical environments, and I mean environments in the most general way, including servers, virtual machines, containers, configuration, databases, among the other things. Sometimes we can use different boxes, other times we can use separate virtual machines running on the same hardware, or they can be on different containers running in a single device. So you can see the two environments, blue and green, uh, may refer to the same database at some point of time. We also need some way of switching incoming connection between the two environments. We'll represent that with the help of a router symbol or a proxy symbol. It can be a router, a load balancer, or a reverse proxy, or like anything which can route the traffic from the blue environment to the green environments. So what are some pros and cons? So the pros is testing partiality, testing parity. This is the feature. Testing parity means that tests truly mirror the reality of production. This is what Dan and Jay were looking for when they devised the blue-green. By running tests on the same hardware and software, they made them more useful and meaningful. Deploy at any time. No downtime means that we can make a release at any time. There is no need to wait for maintenance window. Instant cutover. Users are switched to the new version instantaneously or nearly so. Everyone sees the latest release at the same time. Instant rollback. The cutover works both ways. If we decide to go back to the previous version, we can switch all user back in an instant. Hot standby. Blue-green can save us from the disaster scenarios. Suppose that one data center goes offline, bringing the live environments down. No biggie, we'll switch to the other until the problem is fixed. This will work as long we have had the precaution of not putting blue and green on the same availability zone. What are the cons of blue-green deployment? First is the cold start. Second is the cost. So cold start says user may experience slowness when they are suddenly switched to the new environments. Also, any undetected performance problem are likely to appear at this point. Warm-up jobs and stress tests mitigate this risk. Costs. Compared to the other method, blue-green deployments are more expensive. Provisioning infrastructure on demand helps, but when we are making several scaled-out deployments per day, the cost can snowball. Time. Setting up the blue-green deployment process takes time and effort. The process is complex and has a great deal of responsibility. We may need to do many iterations before we get it working right. Database. Database migration are harder even at the point of being a showstopper. Database schema changes must be forward and backward compatible. We may need to move back and forth between the old and the new versions. The problem is compounded when we have two databases, one for blue and other for the green. Keeping data in sync is a pain. Common strategies to deal with this involves using replication to manage the database read only. So thank you so much for watching today's video, and if you think the videos are helpful, do like the video and subscribe to the channel.